This meeting is being recorded.
Okay, should I start letting people in and then I can at least present our main one and then I'll just swap over as needed.
Yeah, let's do that. Good morning, everyone. We will start in a couple of minutes. Good morning, everyone. We'll just give one more minute for people logging in. Good morning, good morning.
Good morning.
All right. It's 2 minutes past 8, sorry. We got about 25 people now, so I think we should go ahead and start. We have a full agenda. Good early morning, everyone. My name is Rokas, and I'm the Director of Commercial Business at the Montgomery County Green Bank. Thank you so much for joining the Contractor Breakfast. Hopefully that last time virtually, and in the next couple of months, we can do this in person. I will be the moderator today. I have a few colleagues here as well. Josh will be helping out with the slides for the panelists, as well as muting people who are not muted. And Cindy will monitor the chat and collect the questions so the panelists can answer them at the end. This is being recorded and we will distribute slides to everyone afterwards. Before we get to the panelists, we do have a couple of guests as well that I would like to introduce and give them a minute or two. But first, I want to put Steve Morell, our Chief Investment Officer, on the spot here. Usually Tom Deo does that, but he's on vacation. Steve, the last time we had Commercial Contractor Breakfast was about 3 months ago. What has changed in the past 3 months at the Green Bank? If you can just give a 2-minute update to our friends and partners here, that would be great.
Great, thank you, Rokas, and good morning, everybody. Appreciate that you could join and welcome. As Rokas said, this is part of a series that we're looking to continue, and we did before the pandemic, and we've been doing virtually, and hopefully can come back together live soon enough. And really, it's intended to gather all of you and learn from you and learn about interesting topics. The Green Bank has changed pretty dramatically since we did one of these last events, both live and virtual. And so we're really excited to have a larger group of contractors join. In particular, what's changed is that the County Council in Montgomery County voted for an appropriation to the Green Bank to really grow our size. And so please stay tuned for more programming and more exciting programs that we're going to bring on in financial products. And so we're really excited about those developments and really looking forward to the discussion today. So thank you again and welcome.
Thank you, Steve. So our first guest is Mary Travaglini from DEP. Mary, if you could take a minute or so to introduce yourself and let everyone know about the exciting event you are putting together.
Yeah, so thanks. I'll try to keep this brief. We have a first-time event that we're doing on March 19th from 10 to 4. It's going to be on the campus of the Rockville or Montgomery College in Rockville, and it's going to be focused on everything electric. It's called Go Electric, and it's going to highlight solar, battery-powered yard care equipment, all sorts of green energy. There's a huge EV car show. We're hoping to have, or expecting to have Pepco and other partners there with their EV Smart program, talking about how to hook up chargers. We're going to have our solar partners there. And we would really love to see if, and of course, we welcome everyone to come and spread the word. But what we're really looking for is to have somebody assisting around the Green Bank or other areas to kind of talk about the contractor side of things. I think when people show up and are curious about converting their buildings, whether large or small, from gas-powered sources to clean electric sources, or maybe they're getting a fleet of electric vehicles, or maybe even just an individual electric vehicle at a personal home where they want to install solar panels at different scales, or maybe they have an opportunity within a condo system to do a larger scale conversion. I think folks don't honestly really know how those systems work, and they don't know kind of on the how easy or even how complicated it might be in different areas. A lot of times they might assume it's a lot more complicated than it is. And I think it would be fantastic if we had a contractor that could be with the Green Bank there to be able to answer those questions, so that when folks are over talking to the solar folks, or they're talking to the electric car folks, or they're talking to Pepco or our Montgomery Energy Connections folks, Lindsay, et cetera, they could then say, oh, go over and see so-and-so at the Green Bank table. They can talk you through how that actually works. Maybe even having a contractor there that's got things, parts, connections, plugs, et cetera. I think it would be fantastic to have that. And that's one thing that we're looking for. So of course, we'd love for everyone to come and spread the word, but we'd also love if you have a chance after this meeting, to talk amongst yourselves. If you or your company might be able to assist us with that, that's, I'd say, our probably greatest need right now.
Thank you so much, Mary. Our next guest is from WorkSource Montgomery. I believe we have John and Mona. If one of you wants to introduce yourself and speak about resources that you could provide for contractors very quickly, that would be great.
Good morning, everyone. My name is Mona Lisa Tanaza. I am joined here with my colleague, Gary Gerber. We are from WorkSource Montgomery. And what we do is we partner with the Maryland Department of Labor, the American Job Centers, and we partner up with businesses and match them with, we partner up with businesses as well as job seekers and match each other with jobs. So one of the things that we do to help facilitate that is, we facilitate a virtual hiring event, in-person hiring event. As a matter of fact, this month, March, we just started the program of March into Employment, where every day for the month of March, we have a virtual hiring event or an in-person hiring event. So we have quite a few on our books. And so we would be happy to assist any way we can with your companies. We will be putting up our company website here on the chat, and I'll toss it over to Gary to talk about a couple other things.
Thanks, Mona. Hi, everybody. Good morning. My name is Gary Gerber. I'm the Talent Placement Manager for our Business Solutions division of WorkSource Montgomery. So we have the business side, which Mona and I are on, to connect with businesses. And then there's the job seeker side. So we have a bunch of career advisors and instructional training leaders to provide all these services, which, by the way, are free to employers and to job seekers. That's a key. It's we call ourselves the best known workforce development secret in Montgomery County. So there's tremendous number of resources there. This March to Employment that Mona talks about, she's been integral in creating this event, is fabulous. Each day of the month, there's going to be either an employer there talking about, it could be just an info session, but it could be interviewing folks or workshops and so forth. So if you go onto worksourcemontgomery.com, I think Mona probably put it in the chat, and then look on the very left-hand side, as you scroll down a little bit, it'll say programs and so forth, and you just click on that, and the first button there on the left, and it says March into Employment. So check on that, and you'll be able, on the website, we have a listing of all the different, there's like 20 employers now, Mona? 20, we're trying to fill it up.
Yes, that's what,
the whole calendar. And so, and there's a link there to check the link, and it lists all of the different job requirements that these different companies have along, it's in the spreadsheet. And right. So you can click on that link and you can see job seekers can look at those different skills and requirements and so forth, and then click on it and see, all the great companies that are along the top.
Thank you.
X amount. Okay, so thank you very
Gary.
much.
Thank you, Mona. Our last guest is Carolyn Grant. She's no stranger to anyone with the ICF. Carolyn, I believe you have a couple of slides. You're welcome to take a couple of minutes as well before we get into our presentations.
Hey, good morning, everyone. And I'm sorry, Rokas, I didn't have the slides ready to go because I was expecting that they would be incorporated in the presentation. But that's okay. I can, send them to you to be sent out to everybody who attended today. So just as a quick reminder, the Empower Maryland program is available to people who are doing energy efficiency projects. And if you're not familiar with Empower, the Empower Maryland Act was passed back in 2008 by the Maryland legislature. Essentially, it created a mandate for the utilities to reduce KWH usage. And in order to do that, they have set up a variety of programs to incentivize the installation of high efficiency equipment, whether that would be boilers, if you're working for Washington Gas customers, boilers, furnaces, water heaters, or if you're working with the utility, Pepco, and their Energy Savings for Business program, a whole suite of equipment ranging from LED lighting to high efficiency HVAC, scaling all the way from, PTAX to split systems to chillers, and also a variety of appliances and also industrial equipment now, including variable speed compressors. So there is a lot of opportunity out there. If you are familiar with Empower, great. If you're not, but you would like to learn more about incentives, I will put my email address in the chat. And we are here to help and support you and make sure that you're successful using these programs. So thank you very much, Rokas. I appreciate the opportunity to speak.
Thank you, Carolyn. All right, so without further ado, let's start talking about electrification. And I would like to introduce our first panelist, Lindsay Shaw with the Department of Environmental Protection. Lindsay.
Thank you, Rokas. I appreciate it. I think I know most of you on the call in some way, shape, or form, but my name is Lindsay Shaw. I manage energy and sustainability programs for the Montgomery County Department of Environmental Protection. The Green Bank and DEP are very strong partners who work together often. And I would like to ask if Josh would like me to just share my screen, if that would be easier.
I am struggling a little bit. I apologize, everybody.
You got it.
It's taking over my screen. There we go. Is this your slide?
No.
No? It is fighting with me. I apologize,
That's okay.
everybody.
If I'm gonna grab presenter control from you.
That is fine.
Okay, PowerPoint. All right, sorry for the PowerPoint slides early on a Thursday, but helps keep my little face smaller in the little box up there. So Rokas asked me to start off by just talking a little bit about building electrification and why it's so important. We have some pretty ambitious climate goals in Montgomery County. You can see our progress on the screen here. We started measuring our community-wide greenhouse gas emissions by starting in with a 2005 baseline. The most recent year of data that we have is 2018. We should have our 2020 data set done at the end, sometime this calendar year. Takes a long time to get GHG emissions inventories together, which is why we work with our partners at the Metropolitan Washington Council of Governments to help us put these together. Looking at the breakdown of where our GHG emissions come from, you can see the big chunks on the right in that small little pie chart up there. Residential buildings and commercial buildings make up 50% of our greenhouse gas emissions in all of Montgomery County, followed closely behind by transportation and some other sources as well, solid waste treatment, wastewater, agriculture, a couple other fugitive emissions and whatnot. But residential and commercial buildings are our biggest emission sources in Montgomery County. So looking at our climate action plan, which we released back in June of 2021, we're really looking at policies and programs that can address GHG emissions from existing commercial and multifamily buildings right now. We're focused on the big best bang for our buck in terms of emission reductions with most square footage we're looking at right now. So we're looking at commercial and multifamily buildings to start. We expect there to be something for residential buildings coming down the pike in the next fiscal year. But you may have heard that we are starting to look at building energy performance standards for the county. I'm going to talk about that at the end and go into a little bit deeper dive, but that's just one of the many policies that we can use to look at our built environment. We have a lot of incentive programs. You just heard from ICF talking about the Empower Maryland program, one of our favorite programs at DEP to tell people about. Once they benchmark their buildings, which they're buildings that are 50,000 square feet and greater are required to do for non-residential commercial, once they benchmark with us, we tell them about that program because maybe they benchmark their building and they don't love the results that they see. Having that information and having a utility program to call up, get a service provider, get an energy audit, look at what's going on in the building and actually reducing their energy demand and reducing those energy bills is a huge savings here. But we're looking at other programs as well to actually reduce the existing built environment. So in looking at building decarbonization, we got two big buckets. We've got new construction buildings, we've got the existing built environment. I'm going to start off with new construction because frankly, I'm sure that you'll hear from from Chet and from Kyle later on that tackling electrification in buildings at the construction period point is way easier than doing it in an existing building. So codes are the primary tool to get newly constructed buildings to decarbonize. These are being done in Maryland and other jurisdictions. Some other jurisdictions like Cambridge and Massachusetts are exploring banning natural gas hookups. That might be where we go down the road, but right now we're looking at codes. Working through the codes process is one of the most efficient ways to have that technology shift, do it at point of construction, and get that building to shift towards electrification. You may have heard that the county currently has the 2018 International Green Construction Code in effect right now. If you have buildings that are in a design or pre-design phase, please schedule a pre-design consultation with the Department of Permitting Services. They can look at where you are and make sure that your building will be in compliance with the 2018 International Green Construction Code. That is a free service. It does take some extra time, but it's better to do it earlier than later in the process. So highly encourage you to reach out to the Department of Permitting Services, excuse me. The 2021 codes are in development at the state of Maryland level. Montgomery County has the ability that once the state codes come out, we can be more stringent than the state in terms of energy efficiency and moving towards electrification. So we're expecting those codes to come out around June of 2022. Once they're passed in January 21, it takes the state about 18 months to review the codes and get them into effect at the state level. There's actually some legislation at the state right now at the General Assembly that might impact how the codes are being done. It's kind of in flux right now. But once June 22 passes, we have 12 months after that to pass our own version of the code, which is likely more stringent than the state level. In the 2021 codes, the county is exploring a couple different ways of shifting buildings towards electrification. One is electric ready strategies. So if you want to have natural gas in your existing building, you need to wire the building such that an all electric system can be supported if the homeowner decides to switch to electric down the road. So that's a key component there, that it's not banning natural gas, but it is economically driving down the value of gas by saying, I already have to wire this building for electric. Why am I also going to do gas? What a waste of money. Unless the building owner, the homeowner is going to buy this brand new construction home is like, man, I really need natural gas. If it needs to be electric ready, sometimes it might not make sense to also do the gas option. We're also looking at approaching this in a way where there's a matrix of point totals, and the point totals for gas-fired energy efficiency options wouldn't be incentivized, and the electric options would get a higher point value. So there's tons of matrices and the codes to kind of choose your own adventure when you do codes, but still be in line with the codes. So that's one way that we're also looking at shifting away from natural gas, getting the market ready to kind of move away from gas in general. We're seeing trends at the state level. We're seeing trends across the country where natural gas is really not being favored right now. We want to make sure that if we are really serious about meeting those climate goals from that first slide, we need to get away from fossil fuels in general. So I will say that the trends are such that we will be moving away from non-emergency natural gas uses in future code cycles. So this is just it's no secret. It's what we've been trying to do. It's written right there in the climate action plan. DPS has been talking about it. So it's good if you're looking at new construction projects to start thinking about how electrification is going to help you with code compliance down the line. I've mentioned there are some legislative bans coming around. I feel like legislative bans like that are kind of poking the bear. There's a better way to do it. You don't need to be waving a red flag in front of all of the natural gas companies. There's a way to phase down what we're trying to do in a way that makes sense and that they can kind of shift their business model to be focused more on other activities. In terms of code work, I put a link here, and I know that they're going to, the Green Bank's going to send out the slides later. This Codes for Climate link that's on this last bullet here in the section. It's got some really great resources about how you can look at decarbonizing your building in terms of pre-design work and looking at codes and what they mean for your building. So highly recommend that site. That's done by New Buildings Institute with a couple other partners. They've got some really great resources up there if you really want to get into the code stuff. So lastly, for new construction, you see this a little bit, but usually that's done more through the codes. Of course, we have incentives to encourage new construction to be more efficient than the base codes that are existing in Maryland and Montgomery County. So I'm sure other presenters alongside with me are going to talk about the new Green Buildings Property Tax Credit. This is a brand new two-tiered incentive program that's still in the development phase. It's actually a way more complicated tax credit than, well, we knew it was going to be complicated, but it's way more complicated to implement than we originally thought. But what this does is it puts green building certifications second. It says we want your building to be energy efficient. We want it to be a percentage above code, looking at the ZEPI scores, which are they skipped over the 2018 codes that are coming back in 2021. It's looking at the more efficient your building is and getting towards net zero, which electrification will help you get there. The higher that you can get above code, the more of an incentive you get. It kind of ratchets up with multipliers. So it's very cool. And then you get some add-on incentives if your building also gets a number of the green building labels that are recognized in the new program. The old LEED program used to get a tax incentive for just building a LEED building. That's not the name of the game anymore. That program has sunset. We did a lot of outreach and education. I think it was in some of the Green Bank newsletters. Unfortunately, that program doesn't exist anymore unless you were on that intent to apply list. So that process is already in motion. It's already sunset unless you put your name on that list back in 2021. And then the CPACE program has a new construction element. So if you're building your building at or above code, if you get above 5%, you can get more CPACE financing. So that's another incentive there. Existing buildings are more challenging to decarbonize. They already have that emissions lock-in. They already have natural gas systems installed. It's embedded in the building. So I know that our contractor reps are going to talk about that in a minute. More jurisdictions across the country are exploring or have already implemented benchmarking requirements. We've done that here. Energy audit and retro commissioning mandates. Prescriptive required upgrades like lighting switch outs. That's being done more out in the West Coast. Montgomery County instituted benchmarking back in 2014. We have an amendment that's pending that would cover more buildings and require more buildings to meet the energy performance standards. We're going to talk about that more on the next slide. So these existing buildings are just more challenging to electrify. There's a lot of programs that talk about energy performance or benchmarking or some kind of things that you'll do foundationally for your building over time. But we've learned in Montgomery County that if you have a requirement where you are asking building owners to do something, it needs to be paired with an incentive. That's just the way it has to be. Existing buildings are too challenging and too hard of a nut to crack. And a big question that exists, especially when you start talking about multifamily, is who pays for the upgrades. That can really present some affordable housing and equity issues. So just definitely something that we are conscious of when we are doing policy design and program creation. Some of the codes that I talked about before do impact major renovations. So that's another opportunity to look at the existing systems in your building and look at decarbonizing them. But otherwise, we're looking at legislation. So of course, the ones I've mentioned before, but also legislation can apply to incentives as well. So property tax credits, usually those need to be enabled at the state level so then we can offer them locally. Or tax abatements where you aren't taxed on the increased value of your building when you are doing improvements, or through permitting, you get either preferred financing or expedited permitting. There's other incentives at play here that we can consider. And while I have all of you, I just want to close out by talking about building energy performance standards. This is a bill that has been at the County Council since April 1st of 2021. It's been there for quite some time. It's a big bill. It's got some big implications, and it is the foundational policy of achieving our climate action plan goals. What this bill does is it takes our existing benchmarking law, it increases the number of buildings that need to comply. So it drops the square footage threshold down, it adds in multifamily buildings, it more than doubles the number of buildings that need to comply in Montgomery County. And it phases in building energy performance standards. So we're looking at setting energy performance standards based on site energy use intensity, which is a metric that encourages electrification. So if you are an existing building looking to electrify, this will help you meet performance standards requirements. So over time, in that long horizon that we have, it will require most buildings to take some sort of energy upgrade to take some sort of action to upgrade their systems in their buildings. At some point, those systems are going to age out, and we think that the timeline that we've set for BEPS aligns with that equipment replacement time horizon. So something to be watchful of. I'm sure that the second that this law passes, I might run door to door and start telling people. That's how excited I am about it. But of course, we'll communicate through the green bag and let everybody know through the contractor newsletter that you all get. With that, I'm going to turn it over to the next presenter. Thank you again for your time and attention. And if you have any building policy related questions, happy to answer them at the end of the presentations.
Thank you, Lindsay, so much. All right, the next presenter we have is Kyle Wasera with the Capital Efficiency. And Kyle, hey, Josh, do we have Kyle's slides?
Rokas, I'll go ahead and share my screen if that's all right.
Okay.
I think it might be easier just so I'm not saying next slide and whatnot. So, all right, so I'll go ahead and share my screen. Let me know when you guys can see it.
Yep, you're good.
Perfect. So I'm going to be talking about building electrification for existing buildings. Like Lindsay mentioned, it can definitely be a challenge. So we'll just kind of, talk about what the options are. Real quick, so about capital efficiency, we're energy efficiency project developers. So we'll go in, conduct energy audits and retrocommissioning, and then develop a scope of work so that contractors such as yourself can go ahead and design build it. So, we would send it out to you guys to say, hey, here's what we can do to save energy. Can you go implement it? So what I want to talk to you about in terms of existing buildings and electrification is just kind of the process. What do you do to go into an existing building and how do you move towards electrification? So here's the kind of steps that you would take. It seems pretty simple, straightforward, and then we'll just kind of talk about it a little bit further. But first, so here are the steps and we'll go one by one. So first you want to identify in your existing building, well, how is the natural gas systems being used? And most of the time it's for heating, right? You're either heating air or water. And so what are the types of equipment that do that? So on the heating air side, you may have some rooftop units that, have direct expansion refrigerant cooling, but they have gas furnace heating. So you can go ahead and replace those with electric equivalents. Heating ventilators, I'm just trying to present some information here to what would you look out for in your existing building, what uses natural gas. Again, with heating, kind of indirectly, you'll have hot water boilers for reheat systems, maybe like a VAV system with reheat coils. You may have a steam boiler that provides steam for radiators, in like a multifamily situation. There could be gas water heaters for domestic hot water. And then, of course, appliances, mostly focusing in on that multifamily. Gas cook ranges, people love them. It's going to be hard for people to ditch them for electric. And then dryers. So I just wanted to go through kind of one by one to show you, what equipment is natural gas, what can you change to electric, and maybe what are some better alternatives. So as I mentioned, packaged rooftop units on the left, that's kind of, what they look like. And you can just replace them, pretty much equivalently with either a heat pump that would look exactly like it, take it off, plop this new one on. Or a better option would to just go, VRF, which is variable refrigerant flow. And that kind of gives more flexibility where you can do simultaneous heating and cooling. You can have heat recovery options, and it is definitely a much more efficient option. Has its own challenges. You're going to have to run refrigerant piping and things like that. But I'll give you a case study here at the end of the presentation that shows that you can actually retrofit with VRF in a somewhat practical way. So then again, you have hot water boilers. Of course, you can just go straight from natural gas to electric. But something that we'll do when we go into a building is we'll try and see, how is this system working exactly? It's kind of interesting, going back to the VAV with reheat type system. Back in the day, everyone kind of switched from electric resistance reheat to gas and hot water reheat because it was cost effective. And then now we're kind of circling back with the electric reheat because we're moving towards electrification. But there's things that you can do to kind of dial that in from a controls perspective to make it more efficient. So that's why in this category I wrote, is it better? Well, it's definitely more energy intensive, but there's things to consider that can make it a little bit better. Steam boilers, again, you can just do a direct replacement from natural gas to electric. But again, let's try and think about the system. What is the steam being used for? Is it used for sterilization, such as like in a hospital setting? Maybe you can do like UV sterilization. If it's for steam injection for humidifying, you're kind of limited. I mean, maybe you can just directly spray some water. But yeah, we just have to think about what is the natural gas system being used for. Again, domestic hot water. So you have your natural gas, water heater. Again, you can do a direct electric water heater replacement, but some of the newer technologies, you can see there on the right to the left, I guess you can see my screen, I'm pointing at it, is a heat pump water heater, which is more efficient than your standard electric or gas. There's solar hot water heater, but you have to evaluate do we have the surface area and good sunlight to do that? You can also think of point of use, like instant hot water heaters, tankless water heaters. Do we need to have a centralized location to then distribute the hot water, or can we kind of do it at the point of use? In terms of electrification, it kind of is dependent upon the electrical infrastructure and the panels downstream. Can they support that additional load and things like that? But all things to be considered. What I just wanted to show you, and you'll get these slides, is that there are electric equivalents for the natural gas using systems out there. And then lastly, appliances. Unfortunately, there's not really much you can do. You just have to kind of make that change. The best thing you can do is just get an Energy Star appliance. So in terms of calculating energy savings, again, you guys are contractors. I want to keep it into the context of construction and how to make existing buildings, go down the route of electrification. But one thing I wanted to note, just to equip you with this information in case you're talking to owners, and especially because, Lindsay mentioned it earlier, these regulations are focusing on the EUI, or energy use intensity. And without diving into the weeds, there's kind of two EUIs. There's a site and a source. And basically the site means that like what the energy is using at the building. The source takes into account all of the transmission losses. And so what's interesting is that if regulations are going to focus on source EUI, well, when you do fuel switching and you go from natural gas to electric, your source EUI will increase as a result. So not to cause any panic, but I'm just really kind of trying to arm you with this so that you're at least aware if a building owner asks the difference. So in terms of feasibility, like Lindsay mentioned, it can be tough. Going to an existing building, you're kind of limited to the electrical infrastructure. What can you really do? So can you really avoid a heavy up? That's kind of the main question. And so the first thing that you at least want to verify is, what is the utility providing the building? It seems so simple, but sometimes energy auditors out there will often overlook that. So they may specify a 460 volt piece of equipment when the building is only provided 208, 230 to begin with. So at its foundation, get a sense of what is the utility providing. And then the next thing to kind of look at downstream, and the caveat here is, I'm a licensed mechanical engineer. I'm not electrical, but, working in this field, I know a little bit enough to be dangerous. And here's kind of some workarounds in practice. And so what you can do is, look at the panels and basically figure out when you install the new electrical equipment, is the amperage going to, overdraw that panel? And if the electrical room is big enough and, it's according to code, safety standards and things like that, can you do what's referred to as like a tap-in line and basically run a new line to a separate dedicated panel? So what these pictures kind of represent is what that may look like. So just moving left to right, you can see that the building is provided, 108 or 120 and 208 volts. And then the total amperage from the main panel is 600 amps. But what was done, and you see at the top here, is a tap-in line basically kind of bypassed this panel and ran all the way around to a separate panel so that the additional amperage for, in this case, rooftop units could be supported. So don't think necessarily that electrifying an existing building automatically means a heavy up, because there may be, space and safety constraints. If it's possible, you might be able to do some workarounds. Of course, consult an electrical engineer. So I just, real quick, wanted to dive into some case studies. I talked about the VRF earlier. So this is a, 95 unit apartment building in Washington, DC, and, is built in 1941. So very, very old building. They've done what they can do at the surface level. They've done the LED lighting, but really it's built in 1941. The steam piping that went in there, it's uninsulated. So, they're kind of out of options. And so my recommendation to them was, if you're already going to rip down walls and expose those steam piping cavities so that you can insulate them, because that would be the next step, might as well rip them out and just put the VRF refrigerant piping in its place. Unfortunately, there's no easy fix in this scenario, but might as well take advantage of the situation. And so, that's the recommendation. And I just wanted to show you, from a, electrification and gas reduction strategy, what that kind of looks like. So what you see here, these two graphs, is the natural gas use and the electric use from the baseline and the proposed. And really what I just wanted to show you was that basically, gas is used, and this is what, looking at these curves, anyone, someone that works in this would recognize this. Gas is basically used in the winter months for heating, and then the base load is for, the domestic hot water. And so by going all electric with VRF, you can see that, this is the red line is the after. And so you can see that basically you're replacing gas heating with the electric, VRF heat pump heating. And so you're reducing that winter load. And, basically in this case, it was still the domestic hot water and laundry that was left behind. But it's important to understand on the flip side of that, that you're obviously going to increase your electric energy during the winter months where you weren't before. But VRF is very efficient, especially with the heat recovery. You can simultaneously heat and cool and share that heating amongst various units. And so even in the summer months, the cooling load is lower just by nature of being more efficient. So the purpose of this slide is just to kind of understand that, yes, you're going to reduce your, and it seems very intuitive, obviously, but you're going to reduce your natural gas usage in the winter months, but increase the electric as a result. And just something for the owner to be ready for. The good thing is that in terms of escalation pricing, electric energy is kind of forecasted to decrease over time versus natural gas, which is going to increase. And then last, I wanted to talk about, this really cool project I did out in Southern California. I commissioned a combined heat power plant at Grossmont Hospital in San Diego. I don't know if this is electrification per se, but in terms of greenhouse gas emission reduction, they reduced by 90% and saved $180,000 a month. And so it was, a pretty cool project, a natural gas turbine, 4.4 megawatts. And basically, it was heat recovery. So the combustion from that natural gas turbine was recovered to then create steam in what they called a HRSG, or heat recovery steam generator. And that created 3 forms of steam, low, medium, and high grade, that each served its various purposes: domestic hot water, heating hot water, and then sterilization of medical equipment. And then it might seem kind of counterintuitive, but you can actually generate chilled water from heating using an absorption chiller. So that was used in that practice. And that's how, in the end, 90% greenhouse gas emissions reductions and $180,000 a month down to 0. So I'm hoping that this slide basically just spoke about the systems and equipment that you could be on the lookout for to understand the electric equivalents, and that, yes, does an existing building present an additional challenge? It does. But does it automatically require a heavy up? Not necessarily. And so hopefully this helps arm you with that information. Thank you.
Yeah, we had a hand up. Mike, did you still want to ask a question, or are you all set?
Yeah, let's wait for the questions after everyone presents. Let me introduce to everyone Chet Knoop from Spectrum Energy. And Chet, if you want to share the screen, or Josh, do you have the slides?
Got it this time. Apologies for earlier, everybody.
No problem. Okay, so let's go ahead and we're going to zip through this. Some of this stuff is going to be a little repetitive, so I'm not going to try and repeat it because existing buildings and new construction have, a lot of similarities, especially when Kyle was going through potential solutions or alternatives to natural gas. So I'll try not to cover things that have already been covered unless there's a valid point I want to make. So let's go ahead to the next slide, and then you can go to the next one too. And one more. So electrification, I know that Lindsay went over it. Really what I just want to make you aware of is there's really 3 terms that are pretty widely used: building electrification, beneficial electrification, and building decarbonization. So electrification and decarbonization are used widely and will be widely used in the industry. And back to what Lindsay had said earlier, 40%, if you look at the upper right-hand side, 40% of energy consumed in the US is consumed by buildings, houses, buildings, so residential and commercial buildings. And then 50% of all homes in the US are heated with gas. So that's a big chunk of energy consumed with natural gas. And then they're targeting a 9% or 9-degree Fahrenheit increase by 2021. That's what everybody's trying to avoid. We'll go, so just like step 1, where everybody here is obviously in the process of looking at energy reduction and more energy efficient equipment. Step 2 is looking at capacity and transmission. Step 3 is electrification. You don't want to throw all of this electrical demand on a grid that can't support it, or power plants that don't support it. So, so you need to do step 2 before 3. And then step 4, once everything's tied into an integrated network, then you can put in renewable energy. and start to wane yourself off from natural gas, wane yourself off from coal and nuclear. So go to the next slide. So why electrification? Electrification does not make it clean energy. It's just a stepping stone to get everything connected. And again, the real point is connecting all building systems to a single distribution network. Just a couple numbers. So, you know, the first big push, right, to get all of the distribution of natural gas out of buildings and out of homes, right? And that doesn't mean that we're totally off from natural gas, because your power plants will still run off of natural gas. Around 40% of electricity generated in the U.S. is through natural gas. However, if you simply look at the numbers down here, natural gas creates 117 pounds of CO2 per 1 million MBH. So, and coal is at 200, and then fuel oils at 160. So if you just switch over from coal to natural gas, you get a 42% reduction in CO2. And if you switch over from fuel oil to natural gas, then you get a 26% reduction in CO2. So if you want to go to the next slide. So right now in the US in 2020, we used for coal 787 million metric tons of coal and 633 million metric tons of natural gas. So just by simply converting the coal to natural gas, you would save 330 million metric tons of CO2, which is equivalent to 44 million homes. Now, of course, that doesn't just go to residential homes, it also goes to office buildings too. But, you know, we can all envision our house, right, and how much energy we can consume. And to give you an idea too, there's about 139 million homes in the US. So just a simple conversion like that gets us moving forward to a CO2 reduction. Is that an energy improvement? Is that getting us into renewable energy? No, it's not. But it is one step towards it. So go to the next slide. How is electrification progressing? I think Lindsay had mentioned a couple instances. New York City eliminated natural gas in new construction. Maryland, like Lindsay had said, has a bill that's looking at a ban on natural gas for new construction as well. DC's omnibus bill that was passed in 2018 has a goal of 100% clean and renewable energy, so it's going to mandate electrification as well. And then in California, there's over 54 cities and counties that have adopted means of either eliminating or reducing natural gas. Go to the next one, please. Keep going. Okay, so what are the benefits? You know, some things that you don't think about, or maybe you do, but that I feel are kind of obvious. A benefit to removing natural gas from a building is removal of a highly combustible fuel. And so with that, you're going to be taking out something that could, you know, catch fire and burn down the whole building. So not that that isn't possible with electricity, it's just very unlikely. You also can improve your local air quality because you don't have, you know, in essence, a smokestack in every building that's got natural gas, or every house. You reduce the risk of CO and NO2 poisoning through the off-gassing of the burning of, you know, different fuels, a reduction in global house gas emissions, and you get yourself to a single source utility. Obviously, that doesn't take into consideration water, but you don't have multiple gas and electric service. And then again, it gets you into a global network, a combined network for conversion to clean and renewable energy in the future. Keep going. So Kyle had mentioned this. You know, one of the design considerations, the largest one is going to be space heating in a building. It's a large consumer of energy. Usually about 20 to 30% of a building's energy is spent on space heating. And the real option away from natural gas is heat pumps, and more heat pumps. You could go to electric boiler if you're in a situation where you want to have a, hot water plant, a 4-pipe system with chilled water and hot water. But you also need to make sure that all heat pumps aren't the same. And you get a what's called a balance point. And this varies a lot. And I know that I'm talking to contractors on this call, so I'm sure most of you have looked at this. But a heat pump is really sufficient to provide nominal capacity to about 45 degrees, unless you oversize it. And then, so at that point below that, you really need to have electric backup heat. You'll notice that as soon as you start to drop below a point, and it's different with each heat pump based off the capacity that you need in your building, your load, versus the capacity of that heat pump. When it starts to drop off, the capacity really drops off quickly. So you need supplemental electric heating coils, where if you get a high heat model or a mini split or VRF type system, VRF was what Kyle was talking about earlier. They're a higher refrigerant pressure system, allowing for lower temperatures in the system so they can extract heat from outside air at lower temperatures. So they're able to provide heating down to 10 degrees without being lower than the nominal capacity of the unit. This is in general. It all comes down to who's selecting the equipment. So someone can absolutely mess up and select the wrong equipment. So this does not eliminate the need for knowing what you're doing. But in general, those systems work out. Now, in our areas, the design condition for heating is between 11 to 17 degrees. So if you can make it down to 10 at 100% capacity, then you're fine. So what that eliminates is a need for additional wiring and an additional electrical capacity for an electric resistance heat strip in your unit. So if we can go to the next one. The next one, like Kyle said, domestic hot water. He had mentioned heat pumps, electric domestic hot water heaters. Same thing for new construction. We'll go to the next one. So cooking, some other options besides natural gas could be electric range and oven. Very simple, actually probably going back to, original. But there's also induction cooking and there's convection ovens. So those will provide better energy efficiency and better results. So you could look at those options too. And clothes dryers, there's condensing dryer, and obviously the electric dryer is the, fallback as opposed to natural gas. Go to the next one. Now, when you're looking at going in any sort of electrification, you're increasing your service. You're going to have larger transformers. You're going to have more panels and the larger breakers. So that's one thing, like Kyle had mentioned, heavy up, right? So you're bringing more demand of electricity into your building. So you need to make sure you have the proper electrical services for that building. And if not, you have to bring it in. So let's go to the next one. Okay, some technologies that you may want to consider because, as I work in the industry, I'm always thinking of, okay, so I've got a problem. How many different options do I have to solve this problem? Because each building is unique. So some of the technologies to look at, and I'm still waiting for like a new HVAC technology to be brought out to the market. Right now, VRF has actually been around for some time now. I want to say it's 30 or 40 years already. In the US, 20, 25 years. So VRF, it's great because you can transfer energy around the building very easily and efficiently. There's no backup heat required. You can also connect your dedicated outside air unit to your refrigerant loop, And this is being done in Europe, and I'm waiting for it to be brought into the US. You can actually connect domestic hot water to your VRF loop to eliminate a heat pump water heater separate or an electric water heater. And they're extremely high efficient. Variable everything, variable fan speed, variable compressor speed, variable flow. So that's where they make up all the efficiency gains. You have a heat pump chiller, which can provide cooling and heating if you've got a simultaneous load for those. One example would be domestic hot water heating in the middle of the summer when you also need cooling. Or a building where you've got a large server room and you need to cool in the server room year round, and in the winter you need to heat. You can take and transfer that heat to another space through a heat pump chiller. ECM motors, very good, very high efficient, and easy to connect to. Air scrubbers reduce outside air, which can reduce your HVAC equipment load and capacity. I've done numerous calculations and recommendations to owners on utilizing air scrubbers to pull out or to extract CO2 from air in the building and then release it at off hours. And then that's changed and reduced the size of equipment and their energy performance. Low flow fixtures, if that fixture has hot water that goes to it, then you can reduce domestic hot water demand. And then Internet of Things, IoT is huge. That's where everybody's trying to get a lot of savings now. It's a great opportunity. Turn something off when you're not using it. Dial it back when you only need a certain amount of heating or cooling. Magnetic bearing chillers are also good. High part load efficiencies. No oil in the system for losses, for thermal efficiency losses. So that's good. We'll go to the next slide. So how do you justify the cost of electrification? And Carolyn Grant was on earlier and talking about Empower Maryland. So there's utility incentives. Obviously, we're on this call with Green Bank, and Green Bank represents not only Green Bank, but also C-PACE loans, commercial PACE loans. So those are opportunities for funding for a project. There's local tax abatement. Lindsay had mentioned that earlier about Montgomery County's high-performing building tax abatement. And then there's state tax abatement, state energy grants, and then there's federal tax deductions. And by looking at all of these different measures, you can really impact a payback period for a project. And not to mention, right, if you're doing electrification and you're doing energy efficiency improvements, you also have your annual energy savings that play a key role in reducing your simple payback period or improving your ROI. So if we can go to the next slide. So this is a project that we completed probably about 2 years ago. Existing building, office building, 250,000 square feet. We went into the building and the project was a small BAS upgrade. We talked with the owner, we did some analysis, we did an energy audit to find out where their energy was being consumed and what improvements could be done in the building. So we expanded that initial project, which was really just going to be a BAS overlay, to installing VFDs, controlling the flow through this. It was a condenser loop with floor by floor SCUs and a cooling tower on the roof. So we replaced the cooling tower. We did the VFDs on the pumps. We did some other control upgrades. And the total project cost came to $550,000. Well, in doing this, if you look over in the top right-hand side, you'll see that we were able to get $240,000 of our $550,000 project covered by utility incentives. Thank you, Pepco and Carolyn. I'll plug you there. Also, the owner is able to deduct through federal taxes and tax code 179 for the cooling tower at $90,000 of that cost is a tax deduction that they can have. The other one is a tax deduction, a federal tax deduction as well, which came to $75,000. That was for the equipment inside the building. So in total, they got a savings of $405,000. So that left them with a net cost of $145,000, and their annual energy savings were $111,000. So the simple payback of this project was 1.3 years, which is pretty impressive because the initial BAS upgrade they were looking at doing was going to have a cost of $125,000 and was not going to get them a new cooling tower and VFDs, and they wouldn't have seen the 111 in annual energy savings. So last slide, and then I'm done, Rokas. So I was talking about new construction. So here's a new construction project that we're working on with the client. It's a 600,000 square foot multifamily project. They're doing VRF as the HVAC system. They've got LED lighting, and they're doing energy recovery. The total project cost is $2 million. The energy savings are better than code, right? Because we're comparing it to code. It's new construction. There's no existing energy consumption. And that savings, that 111 wasn't updated. The one on the bottom is right at $289,000 a year. So we don't have a breakout of the cost of the HVAC system right now. So we're just going to look at this as total savings. So in this project, right, we're pushing electrification, we're pushing high efficiency. So what's available to people? Well, on this project, we're able to capitalize on utility incentives of the amount $641,300. We're submitting for a grant of up to $200,000, and the local tax incentive is panning out at about $3.5 million. And that's the one that Lindsay had mentioned earlier. So they also are eligible for federal tax deduction, and the cash value of that is $266,000. So in total, this project is eligible for $4.6 million in savings, which if you look down, it actually equates to about a 2.3% of total project cost, which is huge when you talk about the size of the project. And then also they have an annual energy cost savings of about $289,000 a year. So I think that's it. If you want to hit the next slide. Yeah, and then if you want to look at more, NREL did a great multiple studies that you can reference at your own leisure. If you want to go to sleep really well at night, just start reading this. I'm done. Thank you so much, Rokas. I appreciate it. Thank you, everyone.
No, thank you, Chad. This is a fascinating topic, and it's hard to cover everything in an hour. Perhaps we should have a part two. Also, we're always looking for ideas and topics for the next contractor breakfast. If you have any, please feel free to email those to me. Building electrification topic idea came from Chad at Spectrum Energy. So thank you again, Chad. All right, Cindy, do we have any questions for the panelists?
Yes, thanks, Rokas. We do. Before I start, just wanted to encourage everyone, that while we might be out of time, just please continue the conversation. You can reach out to us or any of the panelists. We had one question from Kyle. Would the climate action plan consider biogas any differently? If the gas utility provider switched to supplying biogas, or what would otherwise be considered renewable or green from a greenhouse gas perspective, would the county still allow for that gas usage? And I think that's for Lindsay.
Yeah, I gotcha. It's a complicated topic. When we're talking about renewable natural gas, the devil's really in the details. When they're installed, depending on, it's a case-by-case basis, of course, but when they're installed, in some cases they reduce emissions, in some cases they don't. It is a blended product. overall, we're looking for 0 greenhouse gas emissions by 2035. That's our ultimate goal here. And renewable natural gas still has GHG emissions. So I think in this context, it's worth looking at it for a transition fuel. But if we're going to keep to the county's climate goals here, we're looking at no natural gas. So just keeping that in mind, with our building energy performance standard, we're not looking for full electrification for all buildings. Of course, the standard has yet to be set, but we do realize that in some existing buildings, getting out of natural gas is going to be very complicated or very expensive. There are programs that help and to kind of shave off some of the costs, but in some cases that the infrastructure is too embedded in the building. I'm sure, of course, you contractors always find a way, and I know that you will, but in some cases it might be too expensive of a price tag for, say, an affordable multifamily property or an aging condo building to really undertake. So we want to be conscious of that too when we're doing policy. So we do have some ways to comply with BEPS that aren't full electrification or 100% solar powered. That's not what we're after here. We're after practical energy efficiency reductions using a site EUI metric that Kyle graciously unpacked for us because I kind of breezed through it. So I hope that answers the question, which is there's really no definitive black and white answer on what to do with renewable natural gas.
Thanks, Lindsay. That was the only question in the chat, and we don't have any hands up, so I'll turn it back to you, Ruckus. Thanks.
Mike Kane raised a hand earlier. Mike, do you have a question?
Mike wrote in the chat that his question was answered.
Okay, cool. All right, well, I'm gonna give another minute. If anyone has any questions, feel free to unmute yourself.
First, you'll have to unlock your device.
No questions. All right. Well, if there's no questions, thank you so much for attending this contractor breakfast, and I look forward to seeing everyone at the next one. Thanks a lot, and have a great day.
Thank you all.
Yeah, thank you, Green Bank.
Thank you so
Mike.
much. Have a
Thank
great
you
day.
so much.
Thanks, Marcus. Thanks,
Take
Steve.
care, everybody.
Thank
Take
you.
care.
Bye-bye.
Thank you.